Good afternoon, sixth graders. It's Mrs. Nelson here, and today I'm bringing you a lesson all about matter. This is just an introduction. We won't get too deep, but we will make sure that you know the basics of what matter is. Let's look at these pictures. What do the following objects have in common? Got a basketball, chocolate cake, a phone, and a lot of images down here. Take a look at them and see if you can figure out what they all have in common. If your teacher wants to pause the video and have some discussion, this would be a good time to do that. Did you give up? Well, they are all made up of atoms and molecules, which means they're all types of matter. So basically everything in the universe is matter. Our school is matter, the air we breathe is matter, cupcakes are matter, baby elephants are matter, sixth graders are matter. Matter is everything all around you. Matter is anything made up of atoms and molecules. As of 1995, scientists have identified 5 states of matter. Today, we're just going to be discussing the 3 main types that we find on Earth most often. Matter is also anything that has volume, and we learned about that, and mass. Let's look at this picture. It says the Earth is one large mixture of molecules and gases and solids and liquids. Those are the 3 types or phases that we're going to be talking about today. All right. So we have 3 phases of matter, or 3 states is another way that you can say it. Okay. The first state is a solid. There's also the liquid state and a gas state. Let's talk a little bit more about solids, liquids, and gases. Well, solids have a definite shape. They also have a definite volume. For example, a marble. The shape, it's a sphere. We can find the volume if we use water displacement. Basically, taking a cup of water, placing in the marble, and see how much the water level raises to help us find the volume of the marble. All right, let's look at some examples of solids. Ice, a bike, desks, school bus, clothes. Those are all examples of solids. All right, let's move on to liquids. All right, liquids, they do not have a definite shape. They take the shape of their container, but liquids do have a definite volume. Let's take a look at that. For example, orange juice. Shape? None. Takes the shape of this glass that it's in. The volume? Well, if we wanted to find the volume, we could use something like a graduated cylinder to find the volume of the orange juice. All right, let's look at some examples of liquids. Milk, a big wave, melted chocolate, soda pop, lemonade. Those are all different types of liquids. Let's move on to the third phase that we're going to talk about today, and that's gases. Gases do not have a definite shape, and guess what? They don't have a definite volume either. Okay, let's look at an example. Smoke. Shape, not definite. Volume, not definite. Gases are usually always expanding. They fill the space of whatever container they're in. Here's some examples of gases. Helium. You can see that the atmosphere, or in this case, this water vapor that's coming out of this chimney stack is an example of a gas. The smoke from the fire. Pollution is an example of gas. And of course, oxygen. All right, you guys, let's talk a little bit more about mass. We've talked about this last week, about mass being the amount of matter in an object. It's how we measure how much mass is in the matter. But here's the deal. Mass is also affected by gravity. You guys have heard the word gravity before. It is a force of attraction between two objects. The force causes all objects to pull towards each other. The more mass two objects have, the stronger the pull. The closer the objects are to each other, the stronger the pull. So this is the big question for today. How are mass and weight different, right? When we stand on the scale at home, we say, I weigh 100 pounds, right? But how do we measure what we weigh in mass? Well, we'll learn that a little bit later today. Let's look at just mass for now, okay? We know that mass is a measurement of the amount of matter in an object. We use grams, kilograms, or milligrams to talk about how much matter an object has. Okay? So here we go. Here's our pan balance. We talked about that last week. Mass is a measure of the amount of matter in an object. The amount of matter. Okay, that's mass. And also, mass is always constant for an object, no matter where the object is in the universe. No matter if it's on the moon, no matter if it's on Saturn, no matter if it's floating in our atmosphere, the mass is always going to be the same. It's constant. Okay? We know that mass is measured with a balance. And we can use kilograms, grams, or milligrams to determine or to say how much mass is in an object, okay? All right, now this is where we need to really listen so we can figure out how the two mass and weight are different. Well, weight is the measurement of the gravitational force of attraction of the Earth acting on an object. So we know that the reason why we are remaining on the ground and not floating up into our atmosphere is because of gravity. Well, weight is the measure of the gravitational force on an object. And it varies depending on where the object is in relation to Earth or any other large body in our universe. If we are on Earth, we can measure the weight with a spring scale. So this is just a little scale, and it's almost like you are just holding whatever item that you're measuring up, and it's measuring the pull of that object on the scale. Okay? The difference of weight is that it's measured in newtons. That's how we tell how the weight of an object is that we use newtons. Many people are thinking we use pounds, but actually weight is measured in newtons. I know, pretty crazy, right? All right, let's look a little bit more at weight. Remember what I said, it's the weight is the measure of gravitational pull on an object. Okay, let's compare like a brick to a sponge. Okay, a brick has mass. Earth has mass. Therefore, the brick and the earth are attracted to one another, okay? The weight of the brick is a measure of this attraction by the earth. Now, the sponge, the same size as the brick, but its mass is less. Therefore, the sponge's attraction to the earth is less. The weight is also less than the brick. All right, last slide here, friends. It's confusing, and I know it is, but we have one more thing that I'm going to show you, and hopefully it'll help to clear up the difference between the two. Here's one last slide, and remember, on Earth, gravity is the same everywhere. So on Earth, mass and weight are the same thing. But if you were to go to the moon, they would be different because the moon has a less gravitational pull than the Earth. So the attraction between you and the moon would be less. On the moon, your weight is less. Your mass remains the same though. Remember, it's constant. All right, so there's another video. It's about 3.5 minutes, and it's going to explain mass versus weight to you in a different way. And hopefully, if it didn't make sense when I explained it, that this video will help you and it will make sense to you after you hear it. Hope you have a great day. Thanks for listening, sixth graders. Bye.